Okay, and we're back. So it's been actually not all that long. I guess yesterday was when I last streamed, but it's been a hot minute since I streamed anything with Apache Spark, and I just realized my neck is naked. So I haven't looked at myself in a mirror for the day. My apologies, everyone. Oh, cool. Okay, so we are going to do more work on this. So specifically, what we're going to look at is shuffle file cleanup. Now, in Spark, shuffle files are really important. They're used for storing data as it's being moved between the different computers. And specifically, it's when we're like trying to do operations on a by key basis, and shuffles tend to be relatively expensive. And so losing shuffle files is bad. And so there's a lot of work done to make it so that we're less likely to lose shuffle files. And that's great. It's super useful, except sometimes the shuffle files being there can cause problems, especially if we start to run out of disk space on the nodes. Now, a lot of people use what's called disaggregated shuffle storage, and that's great. It's fantastic. Um, Not currently set up for that in my current environment, so I want to address that. And even then, while you're not going to run out of disk space necessarily, you might run out of, or not run out of. It'll cost you a bunch of money to store data you might not need. Now, Spark uses garbage collection on the driver to determine when to get rid of shuffle files. The problem, though, is if you're working in a notebook, oftentimes RDDs or data frames will be defined in sort of like the global scope, um, or the outermost scope inside of the notebook. And so they'll never go out of scope, and then they'll also never be eligible for garbage collection. And this can mean that, like, if you've got a really long-lived notebook, or maybe you've got a really long-lived Spark Connect session, you might get into the situation where you've got these shuffle files that you just don't need anymore, right? And the computer, it can't fix that for you, or at least like garbage collection isn't going to be able to fix that for you. So I'm going to put on some synthwave royalty-free music from Techno Axe so that we got something to groove to. Alexa, turn on Holden's speakers. Okay. And we're going to start investigating. Okay, cool. So first things first, I did a little bit of work sort of in advance, if you will, where I filed this Jira. And the idea here is essentially like, hey, for really long-lived jobs, especially notebook jobs, this could be useful, and we're gonna have more of those as time goes on. Ooh, that's a little louder than I planned. We're gonna turn it down. But yeah, so the thing is, back in the day, back in Spark 1.0 days, there actually was a TTL-based context cleaner, but it was a strict TTL base. It didn't keep in mind if something had actually been used recently. It was just like, hey, if this has been around at all for this length of time, we should get rid of it. And so I think we can improve on that, and we can make something that is less likely to have the same issues that was had back in the day. So let's go and take a look at the code. This is actually going to take a minute. I'm going to get pull wheel too because I haven't used this computer for Spark Dev for a little bit. We are going to go ahead and we're going to find this Jira. We're going to find the code change associated with this Jira. It's going to take a minute because there's a lot of code changes. I should probably add the commit hash to the Jira once we find it, because that'll make it easier. I did search for it. Yeah, okay. Why is it taking so long? Wait, it didn't find this Jira? Oh, maybe it's because I had a space after it? Or I found the wrong Jira number. Okay, let's go. Let's double check. This is actually what I'm thinking of. Oh, okay, here. Actually, we've got the pull request here that removed it, I think, maybe? Yeah, okay. Was this merged? Oh. Cool. So, it was merged back in 2016 by Reynolds. Man, that's so long ago. Um, yeah. Okay. So this, I mean, yeah. Okay. So, anyways, the idea or theory here is that we'd want to we'd want to restore some of this functionality, but in a bit of a different way, and more to support notebooks. Okay, I'm gonna have to log in here so I can leave some comments on my own issue. Don't think that's gonna work there. Computers. Hmm. Okay, that should do the trick. Oh, okay. Cool. So we're like poke around at it today, right? We're not actually expecting to like necessarily finish anything. We're gonna start poking at it to figure out like what kind of like effort's gonna be involved and like if this is the sort of thing that like, you know, we should carry forward or if it's the bad idea. Bears inner ETL functionality. Okay. Ugh. Let's go find map output. Okay. Oh. Okay. Ah. Okay, okay. Hmm. So what we would want to do, maybe? Store when it's last accessed. Yeah. Okay, yeah. So every time someone calls it get map status, So yeah, we would add like something inside of here to keep track of the last time. Okay. Updating. Okay, we've got our shuffle mic. Yeah, okay. Okay, thankfully, I think I wrote a bunch of the migration code. But I did that 4 years ago, so if I remember how we do that. Let's go take a look at this. Okay. Log manager master endpoint. Okay. Update shuffle block info. Okay. So here we go. So we've got a shuffle block with the thread. Oh. Okay. So this updates the shuffle index block, shuffle data block. Okay, let's go take a look at context cleaner, because that's the thing which actually does the removal of the shuffle blocks. Cleanup task. Yeah. Yeah. Okay, so the interesting question here to me that I'm thinking about is like, oh, hey Shiva. What I'm wondering is, like, would we want to do it? We could do it at the RDD level, right? Could we do it at the RDD level? Hmm. No, because, well, okay, if we did it at the RDD level, when the RD, when another RDD depends on that RDD, and it gets computed, we'll go to that RDD and we'll be like, yo, what's up? And so I could reset the timer. So that could be an option, right? Or we could do something else. What's the other thing that we could do? So we could do it at the RDD level. That's one place where we could put this. If we put it at the RDD level, what would be the benefits that we would get? So when we go to clean up an RDD, what's going to happen? Oh, yeah. Okay. So, or if we, so if we take a look at shuffle RDD. shuffled RDD. Okay. So, yeah, it feels like that. Feels like that to me too, Shiva. Yeah. Okay, so if we did periodic cleanup of the RDDs, if they were hanging around, or more like we couldn't actually delete the RDD object because like that's going to result in bad news bears. But if we can't delete their shuffle dependencies either. Could we get preferred locations? Okay, what about if we did it inside of the RDD? Sorry, I'm just talking this through. So if we did it inside of RDD, the thing which is hanging on to these references, right, would be dependencies. That's not actually gonna. Where are these shuffle blocks? Okay, let's go back to this. Okay, so yeah, persisted RDDs, metadata cleaner. Metadata cleaner type. Clear old values. Yeah. Let's go back to our context cleaner. Let's keep going. Yeah, so yeah, that's where we have the shuffle IDs. So shit, that doesn't sound good. Okay, sorry. Hear a lot of dog barking. Get kind of anxious. Okay. Clean up shuffle. Yeah. Let's go take a look. Yeah. To me, like if someone's marked something as persist, that's semi-intentional. So but yeah. Hmm. Yeah. Map output tracker. So Yeah. I don't think we should do. Okay, so um, okay, where do we get this? Where is this called? That's called in dependency.scala. Okay. Yeah. So, okay, yeah, so this actually is from the list of dependencies. So, the shuffle dependency. Yes, very nerd things. Hi, Emily. So, the question is, like, do we want... So, part of me wants to... Oh, hi, Beth. Yeah, so okay, the shuffle dependency is the thing which is currently triggering the cleanup. Part of me wants to just add a timer inside of the shuffle dependency where we like say like, hey, if I haven't been accessed, I'm gonna go bye-bye. Or more specifically, like if I haven't been accessed, delete my data. Okay, yeah, so this is a finalized task. So the finalized task. Wait, what? Oh. Huh. Okay. Register shuffle for cleanup this. Okay, and then register for cleanup. Cleanup weak reference. Object for cleanup. Task. Okay. So reference buffer dot add. Let's go find reference. What are we doing with this buffer? Yeah. Okay, reference Q. Q. Ah. Okay. Keep cleaning. While not stop. Val reference is equal to reference Q. Okay, let's go clean up task weak reference. Clean up. Okay. Okay. when the referent object becomes only weakly reachable, the corresponding cleanup task weak reference is automatically added to the given reference queue. Okay. That's cool. Also annoying, but that's cool. Okay. So, to me, what I'm thinking of here is we do have a function. We have a function. We call it inside of als.scala. Clean shuffle dependencies, which goes through and cleans the shuffle dependencies on a given RDD. So, and I'm pretty sure that's inside of rdd.scala. Yeah. So, what we could do so we could extend clean shuffle dependencies to take a parameter of if it should recurse down to its parents. Because I could see a case where we've got like a thing that comes off over here and we have the computation continuing to go here. So we wouldn't want, just because this is going away, to get rid of this if we've got like a bunch of other things over here that are still all referencing this. So we could do it inside of rdd.scala. This is continuing to feel, to me, kind of like the place where I want to put it, except let's go take a look. Okay. This returns a sequence of dependencies. And so the dependencies are always going to just point to the parent. And that'll have to be... So I think we could do it based on the dependency time. The last time dependency was accessed. So I think that seems like semi-reasonable to me, right? So in the root of get dependencies, although wait, everyone who's subclass and overridden get dependencies, we'd have to change. Or really, actually, the only ones we care about are shuffled RDDs anyways. So in shuffle RDD, and anyone who's subclass shuffle RDD, is there anyone who's subclass shuffled RDD inside of Spark? I mean, it's and actually, even if they have, it's no one. Okay, let's see if anyone's done that, like, on the internet. Wait, what? Oh, yeah, this is 060. Yeah, it's, cool. Doesn't look like anyone extends shuffled RDD. So we could just do it inside of the shuffled RDD class. And we could have a timer inside of shuffled RDD class which is like the last time I was asked for my dependencies. Oh, interesting. Huh. Yeah. And then the question becomes, do we want to do it on a per partition basis or globally? I think globally, because if anything's referencing it, something else could be referencing it. Although, on the flip side, if you're only pulling from like the head of a collection, maybe we should be more aggressive. But I think we can start with the least aggressive approach. Um, so what we're going to go down here is to do reset the cleanup timer. Right? Because if anything depends on it, they're going to have to call get dependencies. Oh, but they might only have to call get dependencies once. Because the dependencies that we give them back are all valid indefinitely. So maybe we actually do have to do it at the shuffle dependency phase. Oh. Hmm. Or maybe it needs to go. The other possibility is that it goes inside of the block manager master, which would be responsible for essentially like the thing is like I want to figure out where it is that this needs to go such that anytime a block is referenced, we can reset a timer on it. Block manager master might actually be the right place. Block manager. Yeah. So anytime someone asks for the locations of block IDs, or hmm, um, shuffle. Hmm. Yeah. Yeah. Mr. Block manager. Update block info. Hmm. 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 Okay, I need an endpoint. Yeah. That's the second. Okay, update shuffle block info. Update block info. Update block info. Updates the RDD blocks. There we go. Okay. So if we ask it to remove a shuffle, we have to get all of the blocks for that shuffle and then yeah, get blocks for shuffle. Really though, I would want to know, can I get the shuffle ID from the block? Because then when someone asks me where a block is, I can get the shuffle ID and it can reset a timer for that shuffle ID, conceivably. I wonder if I can do that. Does a shuffle block should know what it's associated with, right? Shuffle block. Block info.scala. Yeah, it's got a shuffle ID associated with it. Oh. Hmm. Okay. Okay. Locations. Okay. See, what's the information that we already have? Block status by shuffle service. Mapping from external shuffle service block manager ID to block statuses. Mapping from block ID to set of block managers that have the block. So I would get a block ID. Mapping from hostname to shuffle. Oh, this is not overly documented inside of the code. That's fine. Yeah, so we would presumably be called. So block locations would have to be referenced every time someone did this, right? To like get the right. Should we block? Okay, yeah. So the problem though is that's we get block IDs, and a block ID has, I'm gonna guess, not a ooh. Okay, so a block ID would actually, we could see if it was a shuffle block ID, and if it is, then yeah, okay. Then we actually do have the shuffle ID, and we could track individual shuffles. So, do we want to put this inside of the block manager master? Kind of a weird place to put it. We could have the block manager talk to the context cleaner. So the block manager could tell the context cleaner that a shuffle block had been accessed for shuffle ID X. Or it could not do that. Okay, let's write some notes in the Jira. Okay. Rough thoughts on how we could make a new and improve TTL mechanism in the block manager master when locations of blocks. We can reset blocks. If any of them are shuffle blocks, we could reset a timer for that associated shuffle ID. Not sure where the timer should live. We could have it in the block manager master, or we could keep it in the or we could keep it in the context cleaner, or in the context cleaner. Okay. Or we could keep it in the manager master endpoint. Put in the context cleaner. One possible reason to keep it in the block manager master endpoint is we could potentially expose this information last access time for block migrations. For block migration, for dynamic scale down selection purposes, and maybe block migrations, but those would probably be better served by local tracking access by yeah. Okay. This is a rough sort of thought of how we could go about doing this. Doesn't seem terrible. So yeah, but let's write it down because we're not gonna do it today. This is just like this is what I think we want to do. And we'll write this down. We'll see if Josh, who's the person who worked on TTL related cleaning in Spark last, which is admittedly 7 years ago, which that's kind of crazy, has opinions about it. And if not, you know, whatever. But we'll give him some time to reply, and I think that's good. And I'll come back to this problem later at some point. I'm not super sure when. But yeah, that's the TLDR. Thanks, y'all. Have a good one. I'm gonna go do a 2 o'clock meeting, I think, or something. Either a 2 o'clock meeting or a 2 o'clock cup of coffee before my 2 o'clock meeting. So, thanks, y'all. And thanks for saying hi, Beth and Emily and Shiva. It's I like having folks to